We're going to talk a little bit about automated insights and automated machine learning. I'll read you this quote. Due to the growing data volumes and increased analytic complexity, today's most successful organizations have adopted next-generation analytics that combine the beauty of the human mind with the amazing capability of machine-assisted insights. Great quote. What we're really getting to is, as the market grows, as machine learning becomes more capable and easy to use, you're going to see a bigger intersection between what you're doing day to day and actually applying machine learning models. But before I jump into that, I want to do just a little bit of a level set. We hear about machine learning, we hear about artificial intelligence, we hear a lot of terminology in the marketplace, and I just wanted to give a bit of a level set on how we view the difference between machine learning and artificial intelligence. So machine learning are developed to answer, we call it narrow, well-defined questions as part of a larger process. We would refer to it as, when you're trying to solve a specific business problem, that's where you would use machine learning. Models learn from historical examples. So we'll look at past data and we'll use that historical data to make predictions on new data. When you start to get into the realm of artificial intelligence, there are more larger systems that combine things like predictions that you could get from machine learning, business logic that you've built into your business operations, and of course data. And when you combine all those three, that's where you can get decisions and take action on a larger picture. So here at DataRobot, we focus on machine learning, and our key value proposition is the automation of that machine learning. That's really why that's really why the company was made. And we strongly believe when you apply automation to machine learning, you can do, what takes data scientists a long time to do, faster and more accurately. A little bit about DataRobot before we jump into it. The company's been around since 2012. For over 3 years, we actually didn't sell a product. We used the $124 million in funding that we raised to really develop it. And the key things here is our founders were data scientists. You can see we have some stats on Kaggle competitions, which are data science competitions. And our founders thought there must be an easier way to get through this process of figuring out the best model to solve a problem. And that's what they did with DataRobot. And if you look at our company, we're 400 plus. We have well over 150 data scientists, which we'll talk about a little later. And in the cloud with our models, we've had customers run over 500 million models with DataRobot. So we're continually learning more and more on how to automate the process of machine learning. As we're in Europe, I just wanted to put up a little slide on a lot of our partners. Some of them are here. If you have some questions, here are some partners that support DataRobot and what we do. But to take a step back, let's start with Tableau, right? We're here at the Tableau conference. The Tableau tool is exceptional. They call it answering questions at the speed of thought. It really is a phenomenal way to take a data set and a visual form and start to get some insight and answer questions. And this is a very basic workflow of how Tableau works, but typically you have a worker, all shapes and sizes, but this is our Tableau worker, and they will connect to a data source, and then within Tableau, they'll do some slicing and dicing and visualize to get, a great visual analysis that you can use in your day-to-day to help you make your operations, your business questions. Typically, you're looking here at historical data and trying to figure out what to do next. The question we ask is, how do you see more in your data? And so when you look at this, on the left-hand side, we have, the accuracy of any predictions you want to do or decisions. And then on the bottom, we have the ability to discover patterns in the data, which is a lot of what you're doing when you're doing, machine learning and modeling. And typical business intelligence tools are very good at looking historical data and answering those questions. But then when you want to start looking at patterns in data, when you want to start predicting the data, you really have to move into the realm of statistical modeling. And then as you keep going through that process to get better and more efficient, you get to machine learning algorithms, of which there's many different types. Many are supported open source. But to really nail down those predictions, you want to get to a point where you're actually applying machine learning models to your data. Gartner calls this augmented analytics. So the things that we always hear when we talk to Tableau users are, explore the data, get a sense of the data. Really the core value of what they're doing today is to find the data and then understand why something happened so that you can make changes in the business to more positively affect the outcome. And Gartner calls augmented analytics an approach that automates insight using machine learning, natural language generation, and they really view this as the next wave, right? And we're seeing it in the marketplace. You're hearing about acquisitions, you're hearing about machine learning constantly, and this is why. They say they truly believe that when you apply machine learning to what you're doing today, that gets you to the point of insight. And to think of it like a workflow, right? We want to answer business questions. So when we built this out, we thought, okay, Tableau users today are exceptional at looking at what happened. You have your historical data, you can visualize it, you can start to make decisions on that. The next level is to begin to understand why it happened. Now, you can get why it happened through Tableau, but it does require work. It requires slicing and dicing. It can also often be a more difficult process because you're really digging into the why. And this is where machine learning algorithms can help you get to the insights faster. The next step, though, is once you've got that maturity level around insights, you want to start predicting, right? So, hey, I've looked at the data. I've started to get some insight into really what affects the business change that I'm trying to affect. The next natural step is, well, when I get new data from my customers or from what I'm doing in my business, how do I actually predict that so that maybe I can make more proactive decisions or decisions that are better for the business? And that's really where the predictions come in, what will happen. And then finally, once you've got that data set built, you really start asking what if. So what if I start making these changes in the business? Can I help predict what will happen? Can I help predict, the upside or the potential downside of making those changes? And so where we'd like to help everyone get to is a workflow that's more on automated insights. So where you have the Tableau worker, you have auto insights powered by DataRobot, and we'll definitely show this in the presentation. And then you have the storytelling with Tableau. So you can look at your historical data, but now you start to get insights into that data quickly. So an example could be, we have down in the booth, if you come down and see, when you're looking at real estate data, right? And you want to understand, okay, what's the biggest impact to housing? Andre will cover that in the demonstration, but you can start to get insight and see insight in maybe areas that were not easily understood before. Finally, where this all gets you to is, making the business decision, right? Making the best business decision for the outcome that you're trying to achieve. So I'll pause there, right? We've got automated insights. We talked a little bit about what comes next, right? So within DataRobot and using Tableau together, you can get automated insights. Eventually, as an organization, you're going to want to get into predictions, where you increase the value of your analysis by telling the story and leveraging data science and the models that are out there to help you predict the next steps. And then you eventually want to get it to the what-if analysis, right? So that if you've run a model, you have a business application, you're looking at a business scenario, when you change some levers, you want to be able to run it through something that tells you, okay, here's what we predict the effect will be when you change these levers. And then you can base some of your business decisions, the confidence you have in those business decisions, on how you change those levers. So, you might be great, Mike. Hey, that's awesome. Let's do predictions. Let's do what-if analysis. What's the problem here? The problem is there's an unmet demand. As this becomes more and more prevalent in the marketplace, as you hear about the need for AI, machine learning in the marketplace, another term you'll hear all the time is data scientists, right? Data scientists are the ones that can do this. They understand the data, they understand your business, they understand, the mathematics and the statistics around it. So we just need to hire data scientists. The main problem here is that the supply of data scientists is low. Globally, they estimate, and I know it's been growing because it's very popular to put data scientist in your title nowadays, but we estimate there's somewhere around 250 to 300,000 data scientists globally. There is not enough of them in the world. Even if you went on a campaign to say, I'm just going to hire data scientists, it's very difficult and it's very expensive. And that's where we have the unmet demand, because people are going to leave here. People in the marketplace want models. They want to get into machine learning, but it's hard to do. It's a difficult process. It really is not a viable option anymore to just continually manually build models to meet the demands of your business. We've seen it. Like I said, we employ over 150 data scientists. They're very difficult to find, very difficult to hire. And to have them just do all the models you need in your business, it doesn't make sense anymore. So really, this is where we feel DataRobot can help, right? We are going to turn analysts and engineers into data scientists. People who understand the business well, people like you who use Tableau, you understand your business, you understand your data, but maybe you don't understand, how to program an algorithm in Python, or what, model management, feature engineering, hyperparameter tuning, everything that goes into making a model efficient. Those are things you may not know, but you do know your business and you know your data. The other way DataRobot's going to help get over this barrier is increasing productivity for a data scientist. There's a lot of mundane work that a data scientist does. Think of it kind of like what Tableau's doing for data prep, right? They said 80% of the time you spend preparing your data, and 20% of your time is in Tableau, where you're really doing the efficient analysis. Data scientists are the same. They spend a lot of time preparing everything to do the modeling, which is the important part of the business. And we help them get over that hump. So if you look at it, this is kind of what we consider the prerequisite for a data scientist. And I laugh, we put a unicorn in there, but the reality is to find someone in your organization that has the domain expertise specifically for the vertical or the business that you're in, has the programming skills, knows how to program in R or Python or whatever it's needed to integrate something into even an application, a business application, and then the math and stats, right? They have to understand there's thousands of models out there. What's the right model to use for this business problem? When I need to tweak this model to make it more efficient, what's the right way to tweak it for this type of, say you're doing a binary classification that you're trying to answer, right? It's a very difficult knowledge piece to have. And so when you have someone that combines all three, they truly are, a unicorn in the marketplace. What DataRobot does is we remove the need for programming skills and math and stats. The automation in our machine learning software will do that for you. All you need to be is a domain expert. You have to know your business and you have to know the data. And we know from our experience as Tableau users, you guys understand your business and your data because you're in there all the time, making visualizations, making business decisions. So this helps you get to the next step, which, eventually you can become the unicorn. So at this point, I'd like to, I'm going to introduce one of our unicorns. This is actually Andre Belaguet. He's under that mask, but he's going to go into the demonstration of what I've been talking about and show you how we work with Tableau and some of the automated machine learning topics that I was discussing. So, Andre.
Thanks, Mike. So my laptop crashed like 10 minutes before the presentation, so I hope I won't have any issue with my demo now. Okay, so let me tell you a story. So let's consider I work at a real estate company, and then we are looking at developing new projects in the Seattle area. And what we want to understand as a business is what is driving the price of housing in Seattle. So we happen we have some data set available that we gathered from a website called Zillow. So it's basically a housing sales peer-to-peer website where you can buy houses. And what we have there is plenty of information about the houses or the buildings as well as the prices. As an analyst, let's consider now I'm a business analyst, I'm not a unicorn, and I will use Tableau to start with to analyze my data and drill down into it. And I'll show you how DataRobot could fit into this context to actually derive those insights automatically and get more like understanding of your data, of the patterns more quickly. Let me open Tableau then. I'll show you a quick glance of the data set. Are you able to see, or is it too small? Probably. That's good, okay. So in my data sets, I have actually, each row is a house, and I have access to the sales price of this particular house or this particular building, as well as plenty of characteristics. There are around 100 characteristics, and I'm only showing like 5 of them here. Like, for example, how many cars are there in the garage, or what is the total basement square footage, what is the overall quality of the house or of the district where you live, etc. So what I could do, potentially the first thing I would do is try to have like some, based on my domain knowledge, try to see how the price, in that case the sale price, so this variable, relates to other variables I have in my data. So I would start doing some aggregation. Here I'm looking at, for every district, based on the quality, I would like look at the average price. So I can drill down into the table and understand like, okay, whether I have some patterns here. I could start building some visualizations. So what I'll show you in a second is that we can actually derive those insights more quickly by using like more like statistical and scientific methods. So I'll show you an early stage. It's a beta integration between DataRobot and Tableau, where from Tableau you can directly call DataRobot models and get those insights automatically. So I'll jump to this tab where it's actually connected to DataRobot, and I will ask that I want to find insights related to my sales price. Okay, it doesn't work now. To the sales price based on this history of sales price I've seen, like basically those ads that were on Zillow in the past. So I want to really learn those patterns, and I will ask DataRobot to predict the sales price based on all the other characteristics that are available. So it's not working now, but I click on Starts anyway, and I fortunately saved the results. So the idea is that DataRobot will, the first thing it will tell me, and I display it here, it will tell me, okay, what are the variables or the indicators in the data that are the most related to the sales price in that case. So I can look at the neighborhood. Seems to be quite an important correlation. So if I look at the neighborhood here, I see that the average sales price for the different neighborhoods are more or less high. So it goes from it ranges from less than 100,000 on average up to more than 700,000. So the neighborhood is actually one of the most important indicators. There is a high correlation here. The second one would be the quality of the building. So you see that the higher the quality, the green points indicate what is the average sales price for the different segments of quality. So I see there is another correlation there. So those correlations have been derived by DataRobot and then were put into Tableau. So I'll show you how this works internally. So behind that, that's one of the insights that DataRobot would allow you to generate automatically. But there are a lot of different machine learning models that would try to learn those patterns and mine the most significant ones. And those machine learning models typically rely on heavy programming of statistical languages and libraries. So in DataRobot, I'll be able to do that automatically without having much knowledge about those algorithms. So let me show you how this works. This is the DataRobot interface. The first step is that I will take the dataset I was exploring into Tableau and just drag and drop this into DataRobot like this. So just like in Tableau, I'll be able to first get a quick glance about the different variables that are in my data. We call that in the data science process exploratory data analysis. The idea is just to look at the different variables, the different columns that are in my data, look at the distributions. Something you could easily do in Tableau. With DataRobot, because we're a data science software, we're doing that in the eyes of ensuring you don't have any data that is of very bad quality before you build models. Because if your data is of very bad quality and you start building models out of it, you might actually have wrong patterns. So I'll be able to explore the different variables here in DataRobot. For example, what do I have in the street? I see that it's either a paved street or, I don't know what this is actually, but it's another type of street. Gravel, okay, thank you. Neighborhood, so that was one of the variables that I saw earlier as an important one, so I can observe the distributions as well. So I can basically drill down into the different columns as well. But DataRobot will actually ask me, what problem are you trying to solve? In the case of machine learning, very often you're interested in one outcome or something that you want to predict. In that case, it's the sales price. I'm in a real estate company, so I want to potentially understand for a given house what would be the price because I want to sell this as part of my project. So I'll just indicate that my sale price is my outcome. So there are a few configurations for more advanced data scientists. DataRobot is used by both business analysts and data scientists who are much more advanced who look for productivity. But I'll show you like from a pure business analyst experience perspective how it works. So I would just rely on all the configurations that DataRobot found for this particular problem. So I want to predict the sales price. We call that a regression problem because I want to predict something continuous. And DataRobot will have plenty of options it has already selected for this type of problem. So I'll just click on the Start button. And what will happen is that DataRobot, based on the problem I've defined, based on the data set, it will select among all the possible algorithms and libraries that are used by data scientists to derive patterns within your historical data. It will actually make a list of around 50 algorithms, train them, basically those algorithms will learn from your data the different patterns that allow you to predict the sales price. It will rank the resulting models, predictive models, from the highest quality model to the lowest quality model. How do we measure quality? We usually measure that by using a measure of accuracy. So we compare what the model tells you versus reality on houses the model has never seen before. And it will be like give me a leaderboard of all of my models. Before I drill into that, I will just show you what DataRobot tells me here. Similarly to what I found when I was in Tableau, I can actually drill down into now each column, and I'll be able to see for the neighborhood, I have those orange dots telling me the average sales price for the different neighborhoods. And DataRobot recognized that as one of the most important factors. The overall quality of the building is also an important factor, as we saw earlier. So that's what I also was able to load into Tableau directly. But now let's have a look at, drill down into what model DataRobot is doing in the backend. So I'll click on this Models tab, and this is what we call the model leaderboard. The idea is that there'll be a competition among all of those algorithms. They will all be trained on a data set, and they'll be ranked from the most accurate to the least accurate in the leaderboard here. So that's the top ones will be the best algorithms. On the right of the screen, those are all of the models that DataRobot will run on my, in order to learn the patterns from my data. So I have 2 algorithms running currently. I'll just increase the number of workers here to have more compute power allocated to DataRobot. So unlike Tableau, it's actually not running on my laptop. DataRobot is running on servers in the backend, and I'm just accessing the results of what those servers are crunching. So there are plenty of servers. When I put 20 workers, there are basically 20 processes in the backend, building models, all of them in parallel, as if you had 20 data scientists using those servers to build models. And it will give me all the results and rank them in the leaderboard. So it will really tell me what are the algorithms that are able to derive the best patterns and get the most accurate predictions very quickly without me without me having to really code them, all of them manually. We have a team of around like 30, 40 data science engineers. It's our R&D team. They develop those algorithms so that all of the data science-based practices are embedded into those algorithms. The idea is that those algorithms it's really a workflow of transforming your data set, trying to extract some variables, some columns out of them, and then learning the patterns from them. So if I look at what it looks like in practice, an algorithm is just a workflow like this of data transformation. Each block here is either some data pre-processing or transformation, and some algorithm that learns from the data. We are highly transparent in the sense that all of our models, they try to learn very complicated patterns, but they are always fully documented. So even if you don't know anything about them, you can just drill down and understand the documentation of each of these tasks. Okay, so while it's learning and trying to find the best model, I'll click on this Insights tab, in order to see what some of the insights and visuals that DataRobot would generate automatically. This hotspot is quite interesting. Let's have a look at this. So each of the bubbles here represents a subset of my houses that are, if they are in blue, they are a subset that is a particularly low price compared to average. If they're in red, it means it's a subset of houses that have a very high price. Those subsets are identified by very simple rules. For example, if I take those bubbles toward the top here, this one is a subset, the subset of houses where the overall quality is more than 6, and the garage area, so I guess it's the square footage, is more than 663. So those houses are worth, on average, $288,000. Our average across the entire data set was around 120, so it's much, much higher than the average. And I'll be able to see all of those patterns that have already been mined automatically and identify where there are some hotspots of low prices or hotspots of high prices. Because potentially, as a real estate agency, I might get higher margins on high prices, so I want to identify where those are and whether there are some particular characteristics of those houses that I can potentially build in. Okay, so that's one of the insights. DataRobot will then show me a lot of different insights on the different variables. So before going into this, let me show you what's happening inside a specific algorithm. What we want is that the output of this algorithm to be highly transparent so that as an analyst, I can understand what's happening inside this algorithm. So one thing that I may want to understand, for example, is what are the most important factors that are driving my prediction of the sales price for this particular algorithm. We call that feature impact. I hope it was running because let me kill a few jobs here. I have like not enough workers, so I need to I'm in the queue, so I have to wait for resources. Give it 1 second. So the idea is that when you have a model, you want to understand which variables are important, as well as how all of these variables relate to the output, so that you can potentially be able to kind of understand what is overall driving the price. So you see what we saw earlier, the overall quality of the building is one of the most important factors. There is a new one here, that's the ground living area, so I guess the square footage of the overall building is actually the most important factor according to this particular model. The year it was built is important. Obviously, if it's a very old building, probably it will be less expensive, especially in the US, as well as the overall condition. So all of those factors are driving the accuracy and the performance of this model, but there are all of the factors in the data sets, there are I think around 50, were used into this model. I could very easily simplify my model and just use 3 or 4 and see whether I'd be able to get a good prediction. For example, if I take the top 3, like this, I can create it, and I'd be able to run my model again on the top 3 variables. Okay, so now let's say this model, it makes sense, so the most important factors are here. I'll be able to understand how each factor, for example, the ground living area, relates also to the predictions. But what I want to do potentially is to try and now start consuming it. So we talked about making predictions on new houses or new potential buildings that I've not seen in the past. Those models are actually really good at predicting on data it has never seen before. So if you're trying to identify the best buildings for a new development, and you will want to predict on really data you have never seen before, so it's not exploratory descriptive analysis anymore, it's predictive analysis. So you can actually just drag and drop a file with new houses where you don't know the sales price, drag and drop this into DataRobot, compute the predictions, and then it will give me the estimate for all of those houses. So that's something I could do in the UI. I'll show you a way that allows me to actually do some what-if analysis, because potentially for a given building, I want to understand, okay, if the sales price today is at 200,000, what if I just change, I make the kitchen better? Will it increase a lot or just a bit? So that's the kind of things I want to actually understand as an analyst, because that might be questions I receive from the business. So I'll deploy this model into an application that I'll be able to interact with. So I'll create a test application for sales price, here, like this. I'll set that up. It will take a few seconds to set up a server. What will happen is that this model, if you're familiar with APIs, this model will be accessible via an interface where any other system within your business can actually call it via an API to generate your predictions. In that case, I'll just use it via an interface so I can make predictions and do what-if analysis directly within my web browser. So let's create a record. Okay, that's a building A. I'll put some average values inside. Let's say in terms of ground living area, I have like 2,000 square feet, sorry. The overall quality of this building was 8, and it was built in, let's say, 2005. Okay? And I have other values here. I could change them and just like run a simulation here. I want to call my model now and make a prediction on this particular observation. So I click on get prediction. DataRobot will tell me, okay, for this particular building, the average sales price will be 168, the estimated predicted sales price is $168,000. So it's really on a building I've never seen before. It will actually tell me and explain why this sale price is so low or so high. So actually it's quite high because the overall quality is 8. There are 2,000 square feet, so it's quite a large surface, and the year built is quite recent. So those are indicators of the building being a high price. However, there are some indicators of the building being a low price. So that's why the price was not that high. It was not like 300,000. So the sale condition being allocation, I guess, and the alley having gravel is actually driving the price lower. So let's say as a real estate company, I may be able to change like the alley outside. Potentially, I want to evaluate what would be the impact on the price. So I can find the alley in my datasets, well, if I'm able to find it. Probably I won't be able to find it. I have to drill down. Okay, let's say now actually my quality is not 8 but 4, and my living area is actually only 1,000. I'll be able to refresh my prediction. And then you see that you get a much lower estimate of the price. I could try to simulate and see where I could get a very high price. So potentially if there are some information I can leverage or change, if for example I can change the kitchen quality or the size of the garage, I would want to explore what would be the impact of the price. And I can really optimize my business this way. So it's all about understanding what will happen, so what are the prices on houses I've never seen before, but also what could happen if I change something on a house, what would be the actual estimate of the price. Okay, I hope it was useful. And if you have any question, any feedback, please come to our booth earlier. I'll introduce Keith, who is one of our partners from Infotopics in the Netherlands, and who is a user of both DataRobot and Tableau.
Switch to the PowerPoint again. I think this is fantastic new software. My name is Kees Timmers. I'm a director of Infotopics, and thank you for having me adding some words here. We've been a Tableau partner for 9 years now. We are one of the gold partners in the Netherlands, and I think it was a year ago that we were in Las Vegas at the Tableau conference, and there we met the guys from DataRobot, and we directly saw this is something that's really interesting. We have to dive into this, and now we're in the stage of a couple of months working together, and I'd like to share some the why and some real life examples with you, what we do with it. Can I get this in presentation mode, Mike? Or thank you very much. So getting value out of data is something I've been doing for 25 years now, and for 15 years with Infotopics. The people who know the business should be able to answer the questions. That's what it's all about also when it comes to Tableau, and even more when it comes to DataRobot. DataRobot is helping us achieve that goal even more. What we do, we are working with our customers to help them achieve analytical excellence. We're educating people on their analytical knowledge, on their skills, on their data literacy. Are they able to understand and see data as we think they are? Deliver the right technology, Tableau, Alteryx, and now also DataRobot. And helping them set up the right processes to grow in analytical maturity. That's the process. It's about people, process, and technology. Who are we? We are, as I said, Tableau partner, 15 employees, 15 years in business, and several offices in the Netherlands, close to our customers and close to the people, the 50 people who make this possible. Trainers to data scientists, dashboards experts to data flow experts. So why our newest partnership? And why are we so closely working together? Well, in our opinion, and I think you just noticed that, DataRobot is the next step in enabling business and enabling the business analysts. I've been in this business for 25 years and noticed a lot of changes when it comes to the BI world, about in data analytics world. Nowadays it's rather broadly accepted that business intelligence and reporting should not be led by IT, but should be led by business. And what you see happening is that BI competence centers that were in the IT departments are now shifting up to the business departments, who are now starting to work closely together with IT, and also closely working together with these scarce data scientists. The next step is now about moving predictive analytics to the business, who are now more totally dependent on these scarce data scientists, who have a lot of work to do, who have a lot of coding to do, and the business stays there with their questions. That's why we do it. And these business users, these business analysts, are often the same users as our Tableau customers. So I think this is a great addition. And of course, when you look into the opportunities that DataRobot sees, they are everywhere. They are everywhere, from marketing to logistics, from human resource to risk. There are a lot of opportunities. Well, it's such a lot that we said, let's focus first on a few. So we started slowly to have roundtables with finance, financial institutions, banks, pension funds, and with retails. I will pick one out because this is fresh from the press. PGGM, pension fund in the Netherlands, decided to go work with us and DataRobot. And we are they're now proving that DataRobot is the instrument they are going to use. PGGM is the second largest pension fund in the Netherlands. Core business is pension administration for 2.9 million participants. And on the other side, of course, the asset management and the investment of that pension money of those participants, 14 billion euros, the asset management. And you can imagine there's a lot of risk to be handled there. They have a lot of questions that predictions might come in handy. I name a few. So these are few use cases, and that's the way it works with DataRobot. We define use cases, and when it's really good defined, we start working on it. I'll come back to that later on. So the first one is predict real estate manager effectiveness. As I said, PGGM invests with real estate managers who manage properties. PGGM has a huge database of real estate manager performance, which currently goes unused. Typically, a lot of companies have big data sets waiting just to be mined. Desired outcome, provide insight into real estate managers' characteristics that promote effectiveness and steer investment based on these characteristics. That's a use case we are going to handle with DataRobot. The second one, predict which collective labor agreement applies to the employee. This is about data quality and using machine learning and predictive data quality. Currently, these checks of those millions of people require a lot of manual labor, correcting, incorrecting, or missing labor agreement flags, depending on the collective labor agreement. An employee might not even belong to PGGM. So a lot of companies experience this type of data quality issues. Using a predictive model to correct data could be a very efficient way to improve the value of huge historical data sets. And desired outcomes, of course, reduction in our spend on increasing data quality, thereby streaming and providing, bettering their administrative processes. Reduction in mismatches between employees and pension funds. This one is also interesting. Predict investment opportunities. PGGM scores the companies they want to invest in based on a scorecard system using points and other factors. These currently rebalance their portfolio on a monthly basis based on score. A certain action will be taken which, with regards to the investment. Well, the desired outcome predict whether stock should be kept or should be sold. And then when they are going to invest in companies, it's, well, maybe good to know or to have an idea of the chance that this is going to be a healthy company to invest in, a healthy employer, or is it going to be bankrupt situation? When employers go bankrupt, this impact payment to the PGM fund. Reduction of non-payment due to employer bankruptcy. So we come up with a prediction. Shall we go with this employer or not, or is there a chance based on historical data that this employer is going to be bankrupt? Well, for use cases, we are starting now with describing them, and in a month's time we will get the results out for this pension fund. The amount of work, it's still work. It's not like DataRobot automates everything, but it brings the total amount of work to be done, it decreases it enormously. And this comes because the modeling phase, which normally takes data scientists, well, weeks, months time to get a right model in place. And then a data scientist doesn't know 600 models. So to choose the right one, it takes a lot of time naturally. So this is decreased, but, and that's I think the nice thing of it is it makes us, and Mike was also stating that, it makes us focus on two things. Am I asking the right question? What is the question that has to be asked? What has to be predictive, and how can I be smart in that? And then the other thing, do I have the data? And of course we know the data, but is it correct? Can we join it the right way? Can we make smart calculations so that it goes in DataRobot the right way? There's a lot of work to be done, but you can focus on the right things, on the business questions and getting the right data in. We are very happy to be a partner of DataRobot and looking very much forward to work with you and to work with you. When you have questions, when you need any help, InfoTopics can help you implement DataRobot. Thank you very much.
Thank you, Keith. So we have a little bit of time if there's questions. Feel free, please. Do we have an offline version of the tool? So yeah, DataRobot can be deployed in a few different ways. We have a multi-tenant SaaS service on AWS. It can also be installed on-prem, whether you want to do it through a VPC or on bare metal as well. Yeah?
So when working with the predictive scenarios, can you set a weighted average on the variables that you're setting?
So when we're working on a predictive model, can we set weighted averages? I would even make the question a little more broader. We showed a completely automated process. If you want to tinker with it, do some feature engineering, do some tuning yourself, yes. Everything you see there, like we talked about, is you can manipulate it in any way that you want to. We just showed for business users, you know, the easiest way to do it. Yes? Sure. So can we talk a little bit more about Tableau integrations? Yes. So what you saw on screen was an example of the Tableau dashboard extension .api. We've done a sample integration with that. Tableau, it's in beta, so Tableau itself has to release that product. Once they do, we will look to have that extension API productized as well. What we didn't show was we also work with Tableau's data science API. So if you do some work in DataRobot, you finalize on a model, you can export that model into, say, Python, and then use that model and Tableau's data science API to connect to it and run models. And then, you know, anything you do in DataRobot, you could export it to like a CSV and then have it visualized in Tableau as well. Any other? Yes? Sure, great question. So we showed a very simple process of dragging data into DataRobot. Is there other ways to connect? You bet, yeah. So we can connect to ODBC, JDBC data sources. We've got specific links to certain types of databases like Redshift and Snowflake. We run on Hadoop, so we can access Hadoop data sources as well. Virtually any type of data that has, you know, I would say is in a column, we can use in DataRobot. You bet, yeah. So DataRobot itself, if you want to use it and start to make analysis, all the data has to be in one place that we can access. For data preparation, you could use a tool like Tableau Data Prep. Yes? You bet. So we talked about having all the data in one spot. Your data doesn't have to be perfect. DataRobot will go through a process where it can, you know, impute missing values. It can clean up the data. We also prepare the data for data science by doing various calculations. So again, as long as it's all in one spot and structured in a column format, DataRobot will do through some of the data cleanup for you. Yes?
What about correlations and the variables for secondary effects? Like, are you, let's say, just correlating feature X with your result variable, or what about, let's say, you know, the age of the building? Obviously, depends on the quality of the building might be acting on the age of the building, so that you don't get like these connections and meshing up your model. Is that something that you're detecting?
Okay, yeah, so the question was around correlations and how we deal with that. I'm going to pass it off to the unicorn for that one.
So yeah, DataRobot basically, depending on the model it runs, would do what we call variable selection. So it would identify whether there are some variables that are intercorrelated with each other, and then select either one of the two or share the effect between the two. So it depends on the models, it depends on the techniques. It's actually documented in the blueprints in some cases, and some models would actually even try to make a trade-off between the complexity of the model and the accuracy of the model. So that you select only variables that are not correlated, but highly indicative of what you're predicting. So there is a wide breadth of algorithms. I advise that you come to our booth. I can show them in more detail in the application. And that also reflects the question, do you have models that do weighted averages? Yeah, we have those kind of models as well. It's pretty much any model that would try to predict the target, and a lot of techniques are already built in and implemented. So yeah.
How does this visually think that this seems to be able to relate or to make from the business answer to be able to model or learn, for example, like this model? How long does it take?
So how long does it take for a business user, if they were to start this process, put in some data and look at models, how long does it take for them to learn?
So, good question. They are not supposed to learn all the models. So we have actually, with our business analyst type of users, we have a 2-day training that's tailored for them, where basically we teach them all of the concepts that allow you to frame your problem in the right way, to select the right data to put into your machine learning problem, and then analyze the models in the right way. So you don't need to understand the internals of the algorithm to actually build a good model. You need to understand the outputs, so whether the algorithm is accurate and what is driving this accuracy. And those are concepts that can very easily be learned by anyone who knows the data and the domain knowledge. The idea is really to interact with your data by having a machine that learns automatically those patterns. Then you really don't need to know the math or the programming, and that's what we're achieving with a lot of our clients. We also have, my team is actually data science team working with clients where we provide guidance and support. So when you're a DataRobot user, you can actually ask us any question and we would answer. Yeah.
Yeah, it's called DataRobot University, and if you pass, you get a T-shirt too as well. So. Any other questions? Yes.
You mentioned a bit about some of the automated data cleaning when you bring the data set in. Is there any automated transformations or modifications that will be designed to a data set as well?
Okay, so the question was around, we talked about automated data cleaning. Is there any additional things, transformations for vectors and things like that?
I guess if you have like a continuous variable, would it bucket it up? Would it
Gotcha. Sir.
So when I showed, remember in the demo, I showed the concept of blueprints where you have a workflow in the model that basically goes from the input data up to the prediction. So all of those blocks in the blueprints, it can be more or less complex, but there are transformations that are automated. The idea is that if you're a data scientist, you know what transformation to apply for a given algorithm. If you're not, you actually need to, you can't really use those kind of techniques. And DataRobot would automatically transform data sets so that you mentioned, like for numeric variables, bucket them into segments. Some models will do that automatically. Some of them would not. And so the idea is to find which models are the highest quality when you do it or when you don't do it. And those transformations are applied automatically, and we're very agnostic. We have like something like 60 or 70 types of transformations that are automatically applied in those workflows and would basically form those blueprints. Yeah.
Yes?
Question would be slightly different type of question, also legitimate topics. What kind of companies are you targeting for this product, and where do they have to be on that sort of analytics maturity to take advantage of these models?
Mm-hmm. I would say we currently do a lot with businesses that already understand modeling and maybe actively do modeling. So financial services is a big industry for us. Healthcare is a big industry as well. Your question around, what types of organizations can take advantage of it, I would say, the barrier to entry really is being able to get the data that you want to examine in one place, ready to examine. So if you're doing something historically with Tableau and you're happy with that data set, it's a great starting point to kind of move to that automated insights and actually then get into predictions. But we do have, I didn't put any slides on that, but we do hit across virtually all the verticals, whether it's, manufacturing, retail, there's always marketing questions. DataRobot can be used to score leads for marketing. It's used in telecom. There's a myriad of case studies for that. Yep.
So at one point in your demonstration, did you get like a compliance feature?
Yeah, the compliance feature, so because we work so closely with financial organizations, when you do a model, sometimes, certain organizations will require you to list out exactly what you've done in order to have that model in production, right? Because you could see in the case of, say, if you're using a model to give credit or for a loan, you also have to show that you have no bias, say, towards race or gender, or that, that's one example. So they want the whole process completely documented so that if something does come back, they can look at it and say, okay, we see that you're not taking this into account. Generally, that's done by data scientists manually. It's very difficult to do, and it's often a blocking point from actually putting a model into production just because they don't want to document it. So the compliance feature you saw there is a way of DataRobot auto-documenting that for you. So if someone asks, how did you tweak the model? How did you tune it? What model you're using? What kind of data did you manipulate? We can auto-document it within DataRobot. Yep.
What about model improvement or auto model learning? So you've shown the data set that came from the website, let's say 2015. What about you get a new data set? Would you have to upload it again, get a new model in, or are there ways that the model always fetches fresh data and updates itself?
Sure. And we'll make this the last question because I know everyone's got to go. So it's a model management question. Andre?
I can take it now. So indeed, once you have a model that you're happy with and you have it in production, then you want to monitor if there is new data coming, would the model improve, or is the model performance deteriorating over time? So the idea is that today, everything that I've shown in the demonstration, you can actually automate it with we have an API to do it. So if you have, let's say, one engineer and you want to automate any pipeline or workflow in DataRobot, you can do it via this API. So you could automatically recalibrate the models like frequently every week or so, and we have multiple clients doing it, and monitor and check like the final accuracy, whether it's better than the former model or the model that's currently in production. We are actually like also building this into the application right now to provide this kind of a nice user interface for all models in production, monitor the life cycle of the model, and understanding whether the model is healthy or not, whether like the data that you're predicting on is changing or not. So those are things we are currently working on for the UI, but if you want to automate the process of recalibration and refresh of this model on new data, you can do it already.
Thanks everyone for listening to us and sticking around. If you want to see more, come by the booth. Thank you.